So for this project we're going to be using an ultrasonic sensor as a theremin. So an ultrasonic sensor has a trigger and an echo eye, and one will send ultrasound out and the other will receive ultrasound in much the same way as a parking sensor works on a car. The ultrasonic sensor uses 5 volts of power from the Raspberry Pi. So to return the signal from the ultrasonic sensor we're going to use a resistor to ensure that the signal going back to the Raspberry Pi is 3 volts. This breadboard is explained further in the diagram. To find Python on the Raspberry Pi, we need to go to the main menu, which is located in the top left. Click on Menu, Programming and Python 3. A new window will appear. We need to click on File and New File to open a new editor window, which is where we're going to write our code. So now let's look at some slides which show the code in detail for this project. So the first part of our code is importing a series of libraries to enable extra functionality. The first library being rpy-gpio, which is the standard Python library for interacting with the GPIO pins. The second library is called time, and this handles the pace of our code. The third and final library is called Ultrasonic, and that enables a connection between Python and Sonic Pi. With the imports complete, we now go to setting up the GPIO pins, and in this case we're using the Broadcom pin mapping, which is the default standard set by the Raspberry Pi Foundation. We also add an extra line, set warnings false, to turn off a very verbose error message system. Next we create 2 variables, pin trigger and pin echo, and the numbers 17 and 18 refer to the GPIO pins used to connect the ultrasonic sensor to the GPIO. And in the last 2 lines of this section, we set up the trigger pin as an output, which means that current will flow from the pin to the ultrasonic sensor. And we set up the echo pin as an input, which means it will receive current from the ultrasonic sensor. In the second section of code, we're going to create a function. A function is a way of bundling up code into one big section and then using the name of the function to call it later on in the program. In this case, we're going to call the function Ultra, and the first line of code will mean that it will set the trigger pin to false, in other words, turning the pin off, ensuring that there's no current flowing. We then wait for 0.1 of a second before setting the trigger pin to true and sending a pulse of current to it, which will then send a pulse of ultrasound out into the world. We then sleep for a fraction of a second before turning that pin off. We then create a variable called start time, which records the current time as this pulse happens. And then we create a loop which looks for the input pin. If the echo input pin has a 0, which means it's not received any signal, keep recording the start time. But once the input pin receives a signal and it's pulled high, so it's on, it will record the stop time. Then using a little bit of maths, we're going to create a new variable called elapsed time, which is the stop time minus the start time. We then create a further variable called distance, which is the elapsed time multiplied by the speed of sound in centimeters. And then we change the value of that variable so that it's half, giving us just the distance rather than distance to and from the object. We then print this to the Python shell so we can see how it's working. And then to create an audible note, we create a variable called note and divide the distance by 2. We then set the instrument in Sonic Pi to be a modulated pulse, plays a triplet sound. We then play the note before telling the program to sleep for 0.1 of a second. And that's the end of that function, and we move on to the main body of code, which is a simple while true loop, which is known in Scratch as a forever loop, and we call the function we've just created by its name, and that will run all of the code contained therein. Okay, with the code complete, we're now going to start using our instrument. So we're going to position our hand about 6 inches away from the centre, and we're going to start the code running on the Raspberry Pi. Now the pitch of the note is controlled by having the hand nearer for a lower note and farther away for a higher note. So we'll start at roughly 6 inches.